My name's Nick Krippner. I've been with DeZURIK for 10 years now, regional sales manager on the municipal side of the business. Here today we're going to talk about all things pump control. When we talk about pump control, you need to be able to have controlled opening, you need to be able to have controlled closing, and then you also need to be able to get shut in case of a power failure event. So once you have those things accomplished, you need to have the right capabilities to accomplish those, which is in some cases, traditionally, you're looking at some sort of stored energy source, whether you're talking about hydraulic, low pressure water hydraulic, high pressure oil hydraulics. Here's a different type of technology where we're using an electric motor powered actuator and then coupling that with a mechanical style check valve to accomplish all three of those things. This is a lot more maintenance free kind of approach in regards to accomplishing all those same things. A lot of you may think of what do you do in a situation, you've got the electric motor and the check valve and power failure event, would this not fail in last position? Well, that's exactly correct. But when you couple the torque unit with the traditional mechanical style check valve, the way the yoke is designed, what you end up with is the ability to swing shut just like a mechanical check valve on a power failure event. So first thing, you need to have the logic. That's either done by a local control panel, we have the offer to provide that as well, or by SCADA, or some system that the municipality already has in their thing. We can integrate with that. So that's step one to it. And that needs to communicate to two things. It needs to communicate to the pump itself and to the pump control valve. And then that logic will speak to each other and perform that functionality. On a normal standard startup, the logic is going to say, hey, valve, you're closed. You're gonna remain closed. We're gonna turn the pump on. What that's going to do is you're going to deadhead the pump, you're going to build pressure. Because in order to move water the proper direction that you're trying to do it, you need to have positive pressure. So when you have your static head, say it's 50 PSI, for example. You've got 50 PSI of static head. You start your pump control logic sequence. We want to do a controlled opening situation. When we do controlled opening, the logic will say pump turn on. We're going to build pressure until we receive 50 PSI or higher. And then that is also going to communicate via pressure switch. There's a pressure switch that will trip that will allow saying, hey, we're over 50 PSI. Valve, you can begin to start opening and we're going to start moving water the right direction. And then once it gets to fully open, it'll remain fully open until the logic says, hey, we want to have a standard shutdown. In a standard shutdown scenario, the first piece of the logic will be, hey, valve, start going shut, pump stay on. We want to keep moving water. We don't want backflow to go through the valve. We want to do a controlled slow closure while we're pumping. And then once we hit a limit switch at around approximately 95% shut, that'll trip and say, hey, pump, you can now turn off. And then we'll get shut and there'll be no fluid reversal and it'll be controlled opening and controlled closing. And that's the main functionality of why pump control valves are utilized, is you want to mitigate or even fully eliminate surge pressures. The definition of surge is a rapid change in fluid velocity. So if you extend that time over, you therefore mitigate the surge because you're not creating a rapid change in fluid velocity. Again, just to recap here, this is our CPC Smart Check valve. This is a pump control valve that does not have to utilize stored energy. It's more maintenance free. So the ability to have full pump control capabilities, then you have the availability to utilize electric motor operator and have a pump control valve at the same time.
Hi, my name is Jeremy Gill and I'm a Senior Applications Engineer at DeZURIK. Today we will be showing you the APCO CRF rubber flapper check valve. The way a check valve works is when a pump turns on, flow will open up the disc and the valve will remain open as long as the pump remains on. When the pump turns off, flow will stop and the disc will close towards the seat, keeping the pipeline pressurized. The way this valve works is the disc is located on a 45-degree angle, which has a relatively short stroke. This is a one-piece resilient hinge design. With our 100C, we have a leaf spring. This leaf spring is used for rapid closure of the disc. Another option we have for this valve is an external spring option. This is a coil spring that can be externally adjusted through the cover of the valve. Here you can see a mechanical indicator on the valve. This will show you when the valve is open or closed. Another option we provide is a hold open device in case you ever want to back flush your system. You can crank this open and force the disc to remain open and allow it to back flush.
Hello, my name is Don Bartel. I'm the Vice President of Municipal Sales for DeZURIK, and I've been with the business for 10 years. I'd like to introduce you today to our latest evolution in our legendary line of 6000 series swing check valves. This is our model 6000D. The 6000D is available in 2 through 66 inch with a ductile iron body, stainless steel 316 trim, stainless steel shaft, stainless steel body seat, and also stainless steel cover bolts. It's available in lever and weight, lever and spring, and air cushion configurations. This valve has a very revolutionary seat process. It seats very well at low pressures, but also lasts a long time for the lowest of maintenance. This valve also has a one-piece disc arm and disc connection. No single bolt connections. This valve will last a long time with very low maintenance. It has one of the best head loss characteristics of any check valve that you can buy. This valve also has a revolutionary seat design. The rubber seat cannot overcompress, so it cannot be fatigued by the static head pressure. It's a contoured seat design so that it makes up for any type of angular non-conformances. Any misalignment between the disc and the body seat are taken up by our revolutionary rubber seat design. This valve also comes in a new configuration that we have not had before, that's an oil cushion design. And that is a very good design for non-slam and for taking all the vibration and shock out of the closing of the check valve.
Hi everybody, Dave Purvis here, Regional Sales Manager for Red Valve and DeZURIK products. We're here to talk to you about our TideFlex Checkmate UltraFlex inline check valve. As many of you already know, Red Valve was first to market in rubber duckbill check valve technology. We've enhanced those products over the years, as well as developed mixing systems for clean and dirty water service applications utilizing that duckbill check valve technology. Additionally, we've developed other products, and one of those being our most popular check valve to date, our Checkmate UltraFlex inline check valve. To point out some of the key features of this valve, this slip-in model comes supplied with 2 installation cuffs, one on the downstream side and one on the upstream side. And what that means is you can go to the end of an outfall line, for example, and install the 316 stainless steel expansion clamp on the downstream side. However, what do you do if you can't get to the end of the pipe? So you go farther upstream, down a manhole, and you install the valve utilizing the upstream cuff. The valve only needs to be clamped on one side, and that's typically wherever you have access to. Some other features of this valve are the internal membrane flap. That is the key checking feature to this valve. It's also important to note that this valve, along with all of our other check valves, are 100% elastomer construction, meaning there's no metal or mechanical components that could rust, corrode, need lubrication or maintenance. So the checking flap has newly patented features. There's grooves strategically placed in the saddle, along with an arc notch in the seat and bill area. To put it simply, that allows the valve to open easier with very low head pressure. This valve will crack open with 1 to 3 inches of water column, and then depending on the size and the amount of head pressure, the valve's flap will snap to a near full open flow. This valve is available in several different elastomers to meet the application, and it's available in sizes as small as 3 inch all the way up to 84 inches.
Hi, my name's Gino Bertucci. I'm the Business Development Manager for TideFlex. What we have here is one of the valves that started it all. This is the Series TF1 TideFlex duckbill. This one utilizes a flat bottom design for those installations that are really close to the ground. Back in 1984, the US EPA commissioned us to test alternatives to overflow scenarios. So your CSO, your combined sewer overflow, your SSO, sanitary sewer overflow. We did a period of 2 to 3 year testing. Once we had that valve tested out, we realized that, hey, this provided a lot of great solutions for those applications. All of our valves are handmade in Gastonia, North Carolina. They all hydraulically operate with 1 to 2 inches of differential pressure. Once that 1 to 2 inches is met, the valve will begin to crack open and start letting flow out. As more water starts to come in the pipe, the valve will begin to fully open and more flow will get let out of the valve. also providing that backflow prevention that we are so well known for. With these being handmade in Gastonia, North Carolina, there's a little bit of homework that our end users need to do. For this valve specifically, it goes at the end of the pipe, on the outside of the pipe, so we need to know the exact field measured dimensions of that pipe itself. Once we get those dimensions, we start to build it up with different layers of rubber, nylon reinforcement, different fabrics to build up to that specification of the pipe. This valve here utilizes a curved build design that's standardized on 18-inch and up. That helps the larger valve seal and stay closed. It also helps in areas where tidal flows are coming in. We'll bend it against the flow to not open back up. These come standard with 3/16 stainless steel compression clamps, great for any marine or any water applications. On top of that, we can manipulate the geometry and build of the valve to achieve different backflow ratings and different head losses.